Hello, everyone, and welcome to episode 7 of using Napalm for network automation. So, I have a very simple DLS lab over here. I have these two routers, R2, R3, acting as route reflectors. So, therefore, they have neighbor adjacency with R4, R6, and then R12, R8, and R3. Without wasting much time, I have my Kali machine over here, which is going to act as a control center or a management um, lane for, sorry, a management interface for picking up the BGP neighbors from the route reflectors. Now, I wouldn't explain how to do this setup because I've detailed everything in my previous video in this playlist. So without wasting much time, let's go to the control node. So first off, we're going to test connectivity to all these devices. So ping route reflector 3 responding, ping route reflector 2 is responding. So I'll clear the screen. Now, in my Napalm folder, I'm going to do mousepad, um, get BGP neighbors, BGP neighbors. So let's try to digest everything we have over here. So as explained in my previous video, there's no changes to the upper section of my configuration or my code. It's just I import Napalm and now select the network driver from the Napalm model. I import JSON. JSON is basically for formatting the output. And then we also have the IP address of the route reflectors, which is in the form of a block. So one of these IPs has to be 4. And we have a loop over here. So for every IP in this list, we're going to loop over. We get the network driver, which is the iOS, and then we connect using the credentials to the device. And then we open the connection as stated over here. And then from there, we get to print the IP we are connected to. We get to the app table. Okay. So this is from my previous lesson. So get BGP neighbors. Get BGP neighbors from network device. We are going to connect to the device, each device, get BGP neighbors, and um, the output will be kept in this variable, which is net device underscore output. And then we also push the output into a simple variable called output. From there, we are going to format the output to using JSON to a more readable format. So we have a file name here, and the file name goes by using the IP of that particular device, followed by BGP neighbors. That's the naming convention for the output file. You will see on the screen once the script runs. And then we also have simple output here, which is going to save the output. So with open this file name, which is as this naming convention, then you write, because you're going to write the output into that particular file. So we use f.write. So as we write, use the json.dumps is to format the output. And we sort keys, then we give an indentation of 4, as you can see over here. Then when we are done, we just close the connection. Okay. So without wasting much time, don't trust these IPs. So let me test again. So I'm going to close this window, save. So I'm going to test, check, confirm the IP. This is 134, and this is 135. Okay, so we are good to go. So I'm going to type Python followed by BGP neighbors. I'm going to run the command, which is going to get to the BGP neighbors from the route reflectors. So every BGP neighbor connect to the route reflectors, both of them are going to pull the neighbors from the route reflectors. So I'm going to run the command python bgp neighbor.py. I'm going to run the command. So the command is running. So let's hope everything goes through. And as you can see, we are connected to the first device, the second device. We're going to loop through, and should get output here. Okay, so something seems wrong with the script. Let me check it right away and confirm. So I'll pause the video and then check on the script. Okay, so let me do ls to see where the script was executed to. So ls. Okay. So I forgot to edit the script. So the script should have been given a directory to dump the files, but I forgot to do so. So it dumped the files in the current directory where the script was executed. And that's here. So let's open the first one. So from the first one, you see that's the formatting using JSON. Very nice output. We can see everything. So the first one is 10.10.10. That's everything that you learned from 10.10. And as you can see, we have VPN before unicast traffic. So we are receiving 12 prefix has been sent to this neighbor 10.10, and sorry, and the prefix we have received from that neighbor have the description BGP enabled through and everything over here. We see the AS, we see the remote ID and the uptime. Same applies to this neighbor, as you can see over here 12.12.12. Have the description and everything. So as you can see, we had 4.4.4 also here. Then also have 6.6, have 8. We have to, okay, so that's it. So that's the BGP neighbors from this particular device. So we can close this, check this one too. So same thing applies here. Let me increase the font for you to see. So as you can see, I think the view is better now. Same applies to this device. You have the BGP description, AS, remote AS, everything. Over here, prefixes received, formatting and everything. We have all the neighbors over here, 8.8 and everything. You see the router ID too. So thank you for watching this video. So this video was all about getting BGP neighbors from one device. So in the lab, as I said earlier, it's an MPLS lab with 2 route reflectors. R1 is just acting as a control node, control plane for data forwarding or packet forwarding between these devices. Then we pick an interface from R2, R3 and connect them to our management center to be able to query the devices for information. So thank you for watching this video and see you in my next video.